In this video, I'm going to be going through how to add and subtract rational expressions. I'm going to start this video off by saying something that you've heard me say before. You already know a lot about rational expressions. You already know what you need to do in order to add and subtract rational expressions. We're just going to try to make it more explicit what to do when we see those polynomials. The reason why we already know how to add and subtract rational expressions is because we already know how to add and subtract fractions. You've been adding and subtracting fractions for a long time. You know the steps to adding and subtracting fractions. First thing you need to do is get a common denominator. The second thing you do is you add the numerators. Third thing you do, simplify. These are going to be the same steps that we use in order to add and subtract rational expressions, except I'm going to make one addition. We're going to get one extra rule for adding and subtracting rational expressions. One extra step. And that extra step is going to go in the very beginning, and it's going to have to do with our polynomials. We want to deal with the simplest polynomials possible. So rather than deal with them when they're expanded, we want to deal with them when they're factored. So before we do any of this with rational expressions, we need to factor. And that is the only step that we're going to add. Everything else is the same as what you would do if you were dealing with a fraction. Here's my example. I have 1 over 2x squared. It looks like I forgot the squared there. So let's just fix that. Plus 3x plus 1, and I'm going to add to that 2 over x plus 1. I told you that the one extra step that we need to add when we're dealing with rational expressions is we need to factor. I can't factor the numerators anymore. I can't factor 1, can't factor 2, they're already factored. I can't factor x plus 1 any further either. But I can factor 2x squared plus 3x plus 1. And I'm going to do that with a diamond problem. So I set up my diamond. I remember that since I have a leading coefficient, this 2, I need to multiply it by the product. It's the 1. I get a 2 up top. And my sum is 3, so I have a 3 on the bottom. And I ask myself, what multiplies to 2, adds to 3, and that's 2 and 1. So that's 2x squared plus 2x plus 1x plus 1. I look for common factors between 2x squared and 2x, and that's 2x. 2x times x would get me 2x squared. 2x times 1 will get me 2x. Plus, and I have no common factors here, so I'm going to put a 1 and x plus 1. This factors into 2x plus 1 times x plus 1. Again, if you're still uncomfortable with factoring, please go ahead and watch a Khan Academy video on factoring to give yourself a refresher. So I can now rewrite my rational expression as 1 over 2x plus 1 times x plus 1 plus 2 over x plus 1. I now know I need to get a common denominator. So I look at my denominators, and I see that both of them already have an x plus 1. But this denominator is, the x plus 1 is being multiplied by 2x plus 1, whereas this denominator isn't. That means my common denominator can be achieved by multiplying x plus 1 by 2x plus 1. So I'm going to multiply top and bottom of my second fraction, or my second rational expression, by 2x plus 1 and 2x plus 1. Now I have 1 over 2x plus 1 times x plus 1 plus 4x plus 2 over 2x plus 1, x plus 1. I got this 4x plus 2 by doing the distributive property. I did 2 times 2x, 2 times 1. Now I add the numerators and keep the denominators the same. So I have 4x plus 3 over 2x plus 1 times x plus 1. My last step is to simplify. I cannot factor my numerator any further. 4x plus 3 has 4x and 3 have no common factors. It's not a quadratic, so I can't factor it with the diamond problem. And 4x plus 3 is not common with 2x plus 1 or x plus 1. So this is going to be my final answer. I can't simplify it any further. So I just followed the same steps that I would with any fraction, except for that very first step where I had to factor.